Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm answering question number 11 from the October-November 2023. This is the last question on this paper. This is the paper 1, which is Pure Mathematics 1 from the Cambridge 9709 syllabus. Paper 1, this is variant 3. Question number 11 here tells us about a diagram which shows part of the curve with equation y equals x plus 2 over 2x minus 1 squared. The lines x equals 1 and x equals 2 intersect the curve at P and Q respectively, and R is a stationary point on the curve. Verify that the x coordinate of R is 3 over 2 and find the y coordinate of R. So this question here is about the stationary point. Okay, now the stationary point is a point of zero gradient. Okay, so we can see that from the curve that this is a point where the gradient is 0. If you draw a tangent, it's horizontal. Okay, so at the point R, the important point about that, the gradient is 0. The gradient at R is equal to 0. The gradient at R is equal to 0. And the gradient function is known as dy dx. So what we've got to do is we've got to find dy dx here. So we can see that here they've given us y equals x plus 2 over 2x minus 1 squared. Okay, is our equation. Now what I'm going to do is I'm actually going to rewrite that in such a way that it's easy for us to differentiate, because to find dy dx we need to differentiate. So I'll write this as 2 times 2x minus 1 to the power of negative 2. And what I'm going to do now is I'm going to differentiate this. I'm going to find dy dx. Now when you differentiate a x term, you just lose the x and you're left with the coefficient. Remember, there's a 1 here, so don't forget the 1. Many students wrote this as 0. When you differentiate a constant, you get 0. When you differentiate an x term, it's just x to the power of 1. You're left with the coefficient of x. In this case, the coefficient isn't 0, the coefficient is 1. X is actually 1x to the power of 1, but you write it as x. So when you multiply by the power, you end up with 1. And then when you take 1 from the power, you'll end up with x to the power of 0, which gives you 1. So that's how you end up with 1 when you differentiate it. Okay? So that's something that you have to understand here, very important. Many students just left this as 0 for some reason. Now, when you differentiate this, this is now something where you have a function within another function. Something like, you could say f of g of x. You have a function inside another function. Now here, the main function is something raised to the power of negative 2. Which is differentiated by multiplying by the power. So you have minus 2 times plus 2, which is minus 4. You leave this as it is, but you take 1 from the power. But then you have to multiply. So f of g of x, when you differentiate it, if you differentiate this, you're going to get f dash of g of x. You differentiate the main function, which we've done already just now. That's what we did. And then you multiply by the differential of what's inside the function. So you multiply by the differential of what's inside. So you multiply by the differential of 2x minus 1, which is 2. Okay, so this gives us dy dx. So dy dx equals 1 minus 8. Minus 4 times 2 is 8 over, we can write it as 2x minus 1 to the power of 3. Now, if the question said find the coordinates of the stationary point, then I would have to say let dy dx equal 0 and then solve for x. But in this case, I don't have to actually go that far because they already told us the x coordinate of the stationary point and told us to verify that it is 3 over 2. So we can say that at R, when x equals 3 over 2, dy dx has to equal 0. So let's see if that's what happens. So dy dx equals 1 minus 8 over 2 times 3 over 2 minus 1 cubed. So that's going to be 1 minus 8 over, that's going to be 2 times 3 over 2. They cancel out, leaving you with 3 minus 1, which is 2 cubed. Okay, so it's 1 minus 8 over 8, which is 0. 1 minus 1, which is 0. So therefore we can say the x coordinate of R, the x coordinate of R is equal to 2. XR equals 2. All right, so now we want to find the y coordinate of R. The y coordinate of R. Okay, so we know that we got, it's 3 over 2. Say 3 over 2. 3 over 2. All right, so the y coordinate of r is 3 over 2 and yr, which we have to find. Now, we can find the y coordinate of r by simply replacing the x value into the original equation. So we can say y equals x plus 2 over 2x minus 1 squared. Okay, that was the original equation. So we can say when x equals 3 over 2, then y equals 3 over 2 plus 2 over, now you put 3 over 2 in here, as we saw earlier, we get 1, we get 2, sorry, so that's going to be 2 squared, which is 4. That's going to be 4, because you're going to have 2 times 3 over 2, that'll be 3 minus 1, which is 2. 2 squared is 4, so that's going to be 3 over 2 plus 2 over 4, which is like 1 over 2, so that's 3 over 2 plus a half, which is going to be 4 over 2, which is 2. That's going to be 3 over 2 plus 1 over 2, that's 4 over 2, which is 2. So therefore, we can say that the y coordinate of r is equal to 2. So we can say the coordinates of r are going to be 3 over 2 and 2. Those are the coordinates of r. So we found the y coordinate of r. This is our actual answer there, the y coordinate of r. And there's the answer to this question. That's the first part. Now, if the question hadn't told us that 3 over 2 is the x coordinate of the stationary point, then we would have taken this and we would have equated it to 0. And that's also an alternative method of answering this question, although it takes a bit longer, but it's not really necessary. So I'll just show you here quickly on the side. You would just say 1 minus 8 over 2x minus 3 cubed equals 0. Okay, and then you could just rearrange it. 1 equals 8 over 2x minus 1 cubed. And then 2x minus 1 cubed equals 8. And then when you solve this, you take the cube root of both sides. You end up with 2x minus 1. The cube root of positive 8 is positive 2. So 2x equals 2 plus 1, which is 3. So as we can see, x equals 3 over 2. So that's an alternative method, which is perfectly fine. This is kind of what I think they intend here, because they told us to verify that the x coordinate is 3 over 2. So we find the gradient function, replace the x with 3 over 2, and show that it gives us 0 as the gradient. Therefore, it must be the stationary point. Okay, so there's the answer to question number 11, part A. It's all about gradient functions, differentiation, and so on. And now question number part B says find the exact value of the area of the shaded region. So I've got the diagram over here. We've got to find the shaded region here. All right, now area and equations here should bring to mind something called integration. Okay, now when we integrate a function between the limits here, we're going to integrate between limits 1 and 2. It gives us the area between that graph and the x-axis. So if I just integrated this between the limits of 1 over 1 and 2, it would give me this area over here, which is not the area that we require. Okay, now to find the area that we require, we can use this, because we can find the area of, what's between these two. So I can find the area under this line, the area under this curve, and I can subtract those two areas. It leaves us with the area between them. So there's two ways we can do this. One way is we can find, as we see here, we have like a standard shape, a trapezium. We can find the area of the trapezium and take away the area between the curve and the x-axis. Okay, and we'll get the area that we require. That's one way of doing it, which I think is the easier way. Or we can find the area between the curve and the line. Okay, we can say, let's call the line, let's call this y1, and let's call this y2. If I integrate, okay, y1 with respect to x, so I find the equation of this line and subtract that from that the integral of y2 with respect to x. Okay, and between the limits of 1 and 2, between these limits of 1 and 2, that will give us the area. And that's also the same as doing this. It's taking the equation of what's on top, subtract from the equation what's underneath, and integrating that with respect to x between 1 and 2. So I can find the equation of the line, subtract from it the equation of the curve, and then integrate that expression I get between 1 and 2, and I will get the area required. So both of those two ways I mentioned are perfectly fine ways of doing this question. Now what I'm going to do is I'm going to show you first by using the trapezium. Okay, finding the area of this trapezium. Now to find the area of the trapezium, I need to find the y coordinate of P. And I need to find the y-coordinate of Q. Okay, because I have a trapezium that has this type of shape like this. And we know that the area of a trapezium is given by the distance between the parallel sides, that's h, over 2 times the sum of the parallel sides, which are these two lengths here. So the length of this is basically the y-coordinate of P up here, and this is the y-coordinate of Q up here. So if I find the y-coordinates of P, it will give me this length, the y-coordinate of Q will give me that length, and h is equal to 1, as we can see. It's the difference between these two. All right, so what is the y-coordinate of P? Well, that's given by taking the equation and putting 1 inside it. So you have 1 plus 2 over, that's going to be 2 minus 1, which is 1 squared. That's 1 plus 2, which is 3. Okay, so the y-coordinate of P is 3. That's going to be 2 over, just making sure, 2 minus 1, 1. Yes. Okay, so that's 3. And the y-coordinate of Q is given by 1 plus, 2 plus, because you're going to have 2 instead of x, 2 over, and you're going to have 2 times 2 is 4 minus 1 is 3. 3 squared is 9. 2 and 2 ninths, which is going to be, that's 18, that's going to be 20 over 9. 2 and 2 ninths is 20 over 9. So that's the y-coordinate of Q, right? So I can see that this length A here has now become 3, and this length B is now 20 over 9. I'll leave it in exact fraction form, that's better. Okay, and then what we're going to do after that is we are going to now find the area of the trapezium. So the area of the trapezium is the difference between the parallel sides, which is 1 over 2, times the sum of the parallel sides, which is 3 plus 20 over 9. Okay, which is a half. You can use a calculator for this, but no problem. That's going to be 3. That's going to be 9 over 3 plus 20. That's going to be 9. I need to make it over 9. So that's going to be times 9. 27 over 9 plus 20 over 9, which is 47 over 9. Is that right? Okay, so that gives you 47 over 18. That's the area of the trapezium. Now we got to find the area between the curve and the x-axis. So what I'm going to do, I'll take our equation and I'll integrate it between the limits of 1 and 2. And the equation was x plus, and when we get it ready for differentiation, it will be 2 times, okay, if you look at the 2 times, 2x minus 1 to the power of minus 2, 2x minus 1 to the power of minus 2. That's integrated now with respect to x, not differentiated, integrated. Don't mix the two things. Now, when I integrate something like this, the first term is no problem. You have to add 1 to the power and divide by the new power, so x squared over 2. And now for this, I've got to add 1 to the power. Okay, so I'll have, I'll write it like this, 2x minus 1 to the power of minus 1. So add 1 to the power, divide by the new power, which is minus 1. Put the plus between them for now. And then divide by the differential of what's inside the function. This is reversing the chain rule. Okay, so you add 1 to the power, divide by the new power, and then divide by the differential of what's inside the function, which is 2. Okay, and that's between 1 and 2, the limits. So now I can calculate what that is. Let me just simplify this first here. So I have x squared over 2. This is going to be negative. The 2 will cancel with the 2. I'll have 1 over 2x minus 1 to the power of 1. All right, so now I've got it in a nice simpler form for me to now substitute the values of x in. Now we have to substitute the values inside this. So we're going to end up with 2 squared over 2 minus 1 over, that's going to be 2 times 2, which is 4, minus 1, which is 3, minus, and then I'm going to have here, I don't need this bracket here, by the way. I'm going to have to substitute 1 into them as well. So that's 1 squared, which is 1. So that's a half, minus, and you're going to put 1 in here. So that's 1 over, that's going to be 2 minus 1. So it's minus 2 minus 1, which is 1. So it's 1 minus, a half minus 1. Okay, 1 over 1. Okay, which is 1. So this gives us 2 squared over 2, which is 2, minus a third. And you're going to have, this is going to be minus, and you're going to have minus a half there. Right, a half minus 1 is minus a half. So you end up with 2 plus a half, which is 5 over 2, minus a third, which we can find out very easily. Just make the denominators the same. You can use a calculator for this as well. But if we make the denominators the same, multiply by 3, that's 15 over 6. Okay, minus, you multiply by 2, that gives you 2 over 6. So you end up with 13 over 6. So that means the area under the curve, is given by 13 over 6. So the required area, the required area is going to be the area of the trapezium minus the area under the curve, which is, we found the area of the trapezium earlier as 47 over 18. Okay, so we have 47 over 18 minus the area under the curve, which is 13 over 16. We can make the denominators the same by multiplying by 3, the second fraction, both top and bottom. That's 39 over 18. Multiply by 3, so 47. Take away 39 is how much? Multiply by 3, that's right. So that's going to be 8. Is that right? 8 over 18, which is the same as saying 4 over 9. So the area is 4 over 9 square units. There's the answer to that question using the trapezium as well as integration. As I said, there's another method that we could use, which is based upon this, where you find the equation of the two functions, which we know one of them, and we subtract those two equations and integrate that between the limits of 1 and 2. And I'll show you that as well, just to make it complete. So the other method is to do the integral, and we call this y1, we call this y2, of y1 minus y2 with respect to x between 1 and 2, and that should give us the same area. So first of all, we need to find the equation of line 1, the equation of the function 1. So we already worked out that the coordinates of P were 1 and 3, and the coordinates of Q were 2 and, as we worked out here, it was 20 over 9. We know that we need to know those because we have to find the equation of this line PQ. Okay, the equation of the line PQ, we need to know what it is. So therefore, we can then work out how to integrate between those two functions. Okay, so knowing those 2 points will help us to find the equation. This is a straight line. So the equation of the straight line, you need to know the gradient. So the gradient of line 1 is given by the change in y, which is 20 over 9 minus 3, over the change in x, which is 2 minus 1. So it's 20 over 9 minus 3, which is 20 over 9 minus 9 over 3. 9 over 9, sorry. Sorry, what am I talking about? Minus 27 over 9. 27 over 9 is 3. So that's going to be minus 7 over 9. So we know the gradient of the line is minus 7 over 9. So we can say y minus y1 equals m times x minus x1. So let's use this point. It's an easier point, 1, 3. So y minus 3 equals the gradient, which is minus 7 over 9 times x minus 1. Using that point, we can find the equation of the line, which I'll write over here. So y minus, you can multiply both sides by 9 first to get rid of the fraction. So I'll have 9. In fact, I want to write it as y in terms of x. So I'll make y the subject. So y minus 3 equals minus 7 over 9 x plus 7 over 9. And then y equals 7 minus 7 over 9x. And you're going to have plus 7 over 9 plus 3. Okay, so that's going to be y equals minus 7 over 9x plus, that's going to be 27 over 9 plus 7 over 9, which is going to be 34 over 9. So that's the equation of line 1. So now we can integrate. We can say that minus 7 over 9x plus 34 over 9 minus, and then we have our equation, which is x plus 2 over 2x minus 1 squared. all of that integrated with respect to x between 1 and 2. So if we work out what this equation is, let's simplify a little bit by doing minus 7 over 9 plus or minus 1. So that's minus 16 over 9. Minus 16 over 9x. You have plus 34 over 9. You're going to have minus 2 times 2x minus 1 to the power of minus 2. All of that has to be integrated with respect to x between the limits 1 and 2. Okay, so now we can add 1 to the power. This is a bit more complicated, of course. So you have minus 16x squared over, and then you multiply, you take 1 from the power. Yeah, so you integrate, sorry. You add 1 to power, divide by the new power. So you divide by 2, so it gives you minus 16 over 18, 16x squared over 18, plus 34x over 9. And when you integrate this, you're going to have, this is going to become plus, and you're going to have 1 over 2x minus 1, as we saw earlier. Okay, because you add 1 to the power, becomes 2x minus 1 to the power of minus 1, which goes underneath, and divided by the new power, which will cancel out with, which will be 1 anyway, which will be minus 1, that's what became plus. And then you divide by the differential of what's inside the function, so you divide it by the 2, which cancels with this 2. We saw that in the earlier question. And then we don't have to put the c, because we're doing limits here, between 2 and 1. Put the 2 on top. And that will give us, hopefully, exactly the same answer as before, unless we did something silly. So let's simplify this a little bit first. This is 16 over 18. 2 goes into both of those. That will be 8 over 9. So you have minus 8 times 2 squared over 9 plus 34 times 2 over 9 plus 1 over, that's 3, minus, and then you're going to have 8 over 9 minus 8 over 9 plus 34 over 9 plus, we put 1 instead of 2, 1 instead of x, that will be 2 minus 1 plus 1 over, it's going to be plus 1, just plus 1, because that will be 2 minus 1, which is 1. Okay. And now when we stick this in the calculator, we should get the answer. This is negative, don't forget the negative there, negative 8 times 4, which is 4 to 32 divided by 9. And we're going to have plus, that's 68 over 9. Whoops. Plus 68 over 9. Okay, and then plus 1 over 3. And we got to take away from that. Don't forget the minus as well for this 8 over 9 plus 34 over 9 and then plus 1. And that should give us the same answer, exactly the same answer, 4 over 9. That's 4 over 9. So therefore the area is 4 over 9 square units. Okay, so that's exactly the same answer we got using a slightly different, I think, more complicated method. Sometimes this method is easy, especially when they're both, kind of like curves. When one of them is a straight line, normally you can make a rectangle, you can make a trapezium, as we did, something from the shapes, and it might be easier, as it was, I think, in this case, to use a trapezium for the area of the whole thing minus the area under the curve. But it's perfectly fine to find the area enclosed between two functions by subtracting those two functions, the one higher minus one lower. Okay, so that concludes this question. Other questions from this particular paper can be found in the playlist that will appear in this section over here. Other questions from the topic of differentiation in the playlist over here. Other questions from differentiation in the, integration in the playlist over here. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.